So what you'll notice in this percent composition example is that I don't give you grams. Instead, I'm just giving you a compound, which makes it seem really difficult. But what you will also remember is we know a lot from just this formula. Specifically, we know the atomic masses of each of these elements. And so for these problems, when I don't give you grams, that's what you're going to use, the atomic mass, all right, and molecular mass. So let's look at this really quickly. Okay. For iron, what you need to do is you need to pull out your periodic table and you need to determine the atomic mass of iron. And so when I do that, I find that the atomic mass is 56 once I've rounded. All right? So for iron, Fe, my atomic mass is 56. Okay? And my units are grams per mole. I'm not going to keep writing grams per mole, but that's understood. Now, what you'll remember is that I have 2 iron, so I'm going to multiply this by 2. And what I get is that I have 112 grams per mole as my atomic mass of iron. Okay, so that's iron. Notice I'm using the term grams just like I did with the other problem, but now this is referring to the atomic mass and not just the general mass that you can weigh on a scale. Okay. All right, now for oxygen, I'm going to do the exact same thing, and what I find is that the atomic mass of oxygen is 16. Okay, and that's grams per mole again. Remember, in this problem, however, I have 3 oxygens, so I'm going to multiply this by 3. And so what you find for oxygen is that its atomic mass in this problem is 48. So while iron has 112 grams per mole, okay, oxygen has 48 grams per mole. Now, what I can do in order to determine percent composition is add these up in order to determine the total molecular mass of this compound, which we've done before. All right, so if I add these up, 112 plus 48, what I get in my calculator is 160. Okay, so this is 160 grams per mole. So my total molecular mass is 160. Now what I want to do is determine of that 160, what percent is iron and what percent is oxygen. Well, that's not too bad at all because I know their relative atomic masses. So for example, for iron, it has an atomic mass of 112 in this problem, since there are 2 of them, out of the total 160 that iron oxide as a compound has. So if I divide that, just like I did for the other problem, even though technically it's slightly different, what I find is that I get 0.70. All right? Remember, in order to find percent composition, I need to move my decimal place over 2 places. And so what I get is 70%. Now, 2 options. You can just take 100, subtract 70 from it, and get your percent composition of oxygen. I don't really like doing that. I like being able to use that fact to double check my work. So I'm going to take 48, which is my atomic mass of oxygen. I'm going to divide that by 160, because that's my total molecular mass of my compound. And I'm going to see what percent of this 160 48 is, because that's just how much oxygen contributes to the total of this compound. So 48 divided by 160 gives me 0.3. Well, that works perfectly, because if you notice, if I move my decimal place over 2 places, 1, 2, this gives me 30%, which adds up perfectly to 100%. So 70% of my compound is iron, 30% of my compound is oxygen, and I'm done. All right? As simple as that.